In the short run, where some fixed inputs are combined with variable inputs, the production function is an S-shaped upward sloping curve, TP. This total product curve starts with a segment with increasing slope, followed by a segment with decreasing slope, reflecting the law of diminishing returns. From this TP curve, we can derive the total variable cost curve. In the TP curve, output is a function of variable input. By reversing the horizontal and vertical axis, we get total variable input, TVI. If we multiply TVI by a constant unit cost of the variable input, we get total variable cost, TVC. The rate at which TVC increases is gauged by the slope of the tangent to TVC at a given output level. At Q1, for example, the slope of the tangent to TVC simply indicates the amount of additional variable cost required to produce one more unit of output at Q1. The numerical value of this slope is called marginal cost, MC. Given the inverted S shape of TVC, MC first decreases until MC reaches its minimum at the inflection point. Then MC increases after the inflection point. Thus, the inverted S-shaped TVC generates a U-shaped MC. The U-shape of MC is a reflection of first increasing returns followed by decreasing returns as more and more variable input is combined with the short-run fixed input. When TVC is divided by a given level of output, we get average variable cost, AVC. At Q1, AVC is equal to TVC1 divided by Q1. Since TVC1 divided by Q1 also measured the slope of the ray from the origin to TVC, the ray slope provides a visual indication of the numerical value of AVC, whereas MC is the slope of the tangent at that point. MC1 is below AVC1 because the slope of the tangent, MC1, is flatter than the ray slope from the origin, AVC1. Given the inverted S shape of TVC, AVC first decreases until it reaches the point on TVC where the ray from the origin is tangent to TVC. Afterwards, the slope of rays from the origin to TVC starts to increase, giving AVC a U-shape. Observations. First, AVC reaches its minimum when the ray from the origin is tangent to TVC. Since the slope of this tangency measures both MC and AVC, MC therefore intersects AVC at AVC's minimum point. Second, AVC has a symmetric U-shape because 2 points on opposite sides of the minimum AVC point on TVC have equal slopes. Third, when AVC is decreasing, MC is always below AVC. MC could be rising or falling. Fourth, when AVC is increasing, MC is always above AVC and rising. When the cost of fixed inputs is added, TVC is simply shifted up by the same amount over the whole range of output. When TFC is divided by a given level of total output, we get average fixed cost, AFC. At Q1, AFC is equal to TFC1 divided by Q1. Since TFC1 divided by Q1 also measures the slope of the ray from the origin to TFC, the ray slope provides a visual indication of the numerical value of AFC. Because TFC is a horizontal straight line, the slope of rays from the origin will uniformly decrease as output increases. AFC is therefore a decreasing curve. With the average variable cost, AVC, and average fixed cost, AFC, we can construct the average total cost, ATC. Since ATC is equal to AVC plus AFC, we can add AFC and AVC graphically. For example, ATC1 is equal to AFC1 plus AVC1. Similarly, we can derive other ATC points, and finally, the ATC curve. Alternatively, we can derive the ATC curve by measuring the slope of the rays from the origin to TC. Here is the side-by-side comparison. These two methods generate identical ATCs. Notice that the gap between ATC and AVC is narrowing with higher output because AFC is falling as output increases, and MC always intersects ATC and AVC at their minimum points. Why do we need AVC as well as ATC? In the short run, the fixed inputs must be paid for whatever the level of output might be. So as long as the unit price of the output is higher than AVC, some of the fixed costs will be covered. The business is better off operating than shutting down. In the long run, unit price of the output must be at least equal to ATC to cover all economic costs. And why do we need MC? We need MC because pricing should be based on MC and not on ATC. To maximize profit, we need to know that the unit price of output is not only higher than ATC, thus covering all costs, but also that the additional cost of the marginal unit of output, MC, is not higher than the unit price.